In this chapter, we'll be studying about oxidation, reduction reactions, and what is oxidation, what is reduction, different definitions, and then how to find the oxidation number, and explanation of the redox reaction based on reduction and oxidation of the oxidation numbers. And at last, second part of the tute is balancing redox ionic half equations and overall equation in acidic media. So there are two sections for this. The first part is mostly what we have discussed in O levels as well. As for the reduction and oxidation, as you know, you can define reduction and oxidation in terms of oxygen, hydrogen, and electrons, which we have done for O levels. So oxidation is gaining of oxygen to a species, and reduction is losing of oxygen from a species. Also, oxidation can be defined as losing hydrogen, reduction is gaining hydrogen, or in terms of electrons, we can say oxidation is loss of electrons, reduction is gaining of electrons. For that, remember the term oil rig, offshore oil rigs, extract crude oil. Oil is oxidation, oil stands for oxidation is loss of electrons, and rig is reduction, is gaining of electrons. Now, these three definitions already you have heard from your levels. Now, the fourth definition of oxidation and reduction is based on the oxidation numbers. Now, what is oxidation number? Oxidation number is defined as the combining power of an element in a compound. The combining power of an element in a compound. What is meant by combining power is that, for example, if you take aluminium and oxygen, right? You get Al2O3. So this Al, the valency of aluminium goes to oxygen, valency of oxygen goes to aluminium. So the combining powers are 3 and 2. In fact, they are the valencies, right? But when it comes to oxidation number, unlike the valency, we are very particular about the sign. Now, valency, don't worry about the sign, right? If I say valency is 2, that can be +2 or -2. But for oxidation number, the sign is a must. So it's either positive oxidation number, or you can have a negative oxidation number, right? So an element has a positive oxidation number when an atom loses electrons. Where it loses electrons, it forms positive oxidation state. For example, sodium losing electron, sodium plus. Magnesium losing 2 electrons, magnesium 2 plus. Aluminium losing 3 electrons, you get aluminium 3 plus. Likewise, an atom gains electron, you get the negative ion. 2 electrons, dinegative. 3 electrons, trinegative. Likewise, the oxidation number can be either positive or negative. Positive oxidation states are achieved when a species loses electron, and negative oxidation state is achieved when a species gains electron. Clear? So in terms of oxidation numbers, oxidation is defined as increase in oxidation number. Look at this. Cuprous losing electron to form cupric. You know how to name using the suffix -us and -ic, right? Us is when the oxidation number is lower. Now Cu plus is cuprous. -ic is when the oxidation number is higher. Fe2 plus loses electron to form Fe3 plus. Fe2 plus is ferrous. Fe3 plus is ferric. Now, when the oxidation state is increased from plus to 2 plus, or from 2 plus to 3 plus, right? What happens? How we can increase the oxidation state? By losing electrons. When a species loses electrons, it increases the oxidation state. Clear? So losing electron is what? Oxidation. So the fourth definition of the oxidation is an increase in oxidation number. because increase in oxidation number requires losing of electrons. Increase in oxidation number requires losing of electrons. So losing on is oxidation. Oxidation is defined as oxidation. Look at the opposite. Let's see what happens when oxidation number is decreased. Now see, copper 2 plus can gain electron and form copper plus. Decrease in oxidation state. That is cupric to cuprous, ferric to ferrous. Oxidation number has decreased. Decrease in oxidation state is referred to as reduction because decrease in oxidation state requires gaining of electrons. Decrease in oxidation state requires gaining of electrons. So gaining of electrons is what? Reduction. So that's the next definition of reduction. So reduction is losing oxygen, gaining hydrogen, gaining electrons, and it's also defined as the decrease in oxidation number. Clear? These are the 4 definitions of reduction and oxidation. So define the term oxidation number, write the definition. The combining power of an element in a compound. Next, explain how oxidation number could be negative or positive, right? When an atom loses electron or electrons, when an atom loses electron / s or electrons, it gains the positive oxidation state. You can copy the 3 examples which I gave before. The positive oxidation state 3 examples. This sodium, magnesium, and aluminium. Right, please copy the examples. Sodium, magnesium, aluminium.
You are currently the only person in this conference.
Can you hear me now? I'm sorry, I got disconnected. Can you hear me now? The sound clear? I'm sorry, got disconnected. Right. Okay. That's examples. I hope you copied the examples. And the next is continue the note. Likewise, this we are in question B, 2B. Likewise, an atom gains electron or electrons. Second example. Likewise, an atom gains electron or electrons. It forms the positive oxidation state. Likewise, an atom gains electron or electrons, it forms positive oxidation state. I repeat again, the second example. Likewise, an atom gains electron or electrons, it forms the positive oxidation state. Sorry, negative oxidation state, I'm sorry. When an atom gains electron or electrons, it forms a negative oxidation state. Let's copy the three examples. This chlorine, oxygen, and nitrogen. Chlorine gains 1 electron, form chloride. Oxygen gains 2 electrons, oxide. Nitrogen gains 3 electrons, nitride. So, as I mentioned before, just to recap, oxidation is gaining oxygen, losing hydrogen, losing electrons. Oil rig, oxidation is loss of electrons. Reduction is gaining electrons. Reduction is the opposite, losing oxygen, gaining hydrogen, and gaining electron is reduction. And in terms of oxidation number, now we know what is oxidation number. That's a combining power of an element in a compound. That's basically valency. But the oxidation number has a sign, whereas it's not important to put the sign. So in terms of oxidation numbers, you can see increase in oxidation number is defined as oxidation. Cuprous to cupric. To increase the oxidation number from cuprous to cupric, you need to lose electrons. Likewise, increase in oxidation number is always oxidation because it requires losing of electrons. Oil rig, oxidation is loss of electrons. Likewise, gaining, decrease in oxidation number is by the gaining of electrons. See, oxidation number has decreased from 2+ to plus by gaining electrons. So gaining electron is reduction. So reduction is decrease in oxidation number, right? So that's the fourth definition of oxidation and reduction. Increase in oxidation number, therefore, defined as oxidation, and decrease in oxidation number is defined as reduction. So you can define that here. Increase in oxidation number increase in oxidation number requires losing of electrons. Increase in oxidation number requires losing of electrons. Therefore, it is oxidation. Increase in oxidation number requires losing of electrons. Therefore, it is oxidation. You can copy these two examples. The next point, likewise, decrease in oxidation number. Likewise, decrease in oxidation number requires gaining of electrons. Therefore, it is reduction. Therefore, it is reduction. Copy these two examples, ferric to ferrous, cupric to cuprous. Right. So let's see how reduction and oxidation has taken place in these reactions in terms of oxygen and hydrogen. Now see, this copper oxide has turned to copper, so it's losing of oxygen is reduction. Hydrogen has gained oxygen, so it is oxidized. So likewise, can you show in each reaction which species is reduced and which one is oxidized? So I have done the first one for you. Please try the rest. So ammonia to nitrogen monoxide is losing of hydrogen, gaining of oxygen. So this is oxidation. And oxygen has gained hydrogen, so it's reduction. Magnesium has gained oxygen, so it's oxidation. Carbon dioxide has lost the oxygen, therefore it's reduction. Hydrogen sulfide has lost the hydrogen. Now losing hydrogen is oxidation. Losing hydrogen is oxidation. It's just like losing electrons. And hydrogen has gained, chlorine has gained hydrogen, therefore it's reduction. Carbon monoxide has gained oxygen, oxidation. I2O2 has lost the oxygen, therefore it's reduction. Please check your answers.